students, in the day 3 of the chemistry chapter number 1, so we'll learn today the types of the chemical reactions. Okay, as we already know the chemical reactions, here the substance like reactants combines to form a new substance called as the product, right? And now we'll learn the different types of the chemical reactions, and here you will able to know what types of compounds they will form. Okay, so broadly the types of the chemical reactions here in the book, according to NCERT CBSE books, around 5 types of chemical reactions are given, but broadly again, so we divide it into the different types again. That means that we can include some other types of reactions are also around the 14 types of chemical reactions, including these 5 types of reactions we can discuss. So let's learn. The first types of the reactions is the combination reactions. Combination reactions. Okay, so definition is like this: those chemical reactions in which 2 or more reactants combines to form a new product. Okay, so 2 or more reactants, they can combine to form a new product. So generally how we can write A plus B to form AB. That is the 2 more reactants combined to form a single product. For example, here, that's example we already discussed, nitrogen and oxygen to form ammonia, NH3, right? Or if we want to give some more example, that is the say zinc plus chlorine to form zinc chloride, right? So many others are also there, right? So this is a combination reactions, right? Okay, and next we can proceed to the decomposition reactions. More or less same, only here just opposite we can say. Those chemical reactions in which what we're going to do, a single reactants is decomposed, or you say breakdowns to form 2 new or 2 or more, you can say, okay, 2 new products. Okay, are called the decomposition reactions. Okay, see in the examples. Calcium carbonate. Okay, when we heat it, okay, or just simply we can write the heat also, or we can write delta. In chemistry, this triangle, it is a Greek letter called as delta. It denotes what is heat. Okay, here it will form calcium oxide plus what is that? Carbon dioxide. Calcium oxide and carbon dioxide, it will form here. Okay, so this is what is that? A decomposition reactions. Okay, and also see water H2O, and this reaction is also called as the thermal decomposition. What is that? Thermal decomposition reactions. Okay, another one is the water. So when we pass electricity, or electrolysis also we call it, okay, electricity. When we pass electricity in this water, here it gets decomposed into hydrogen and oxygen. Okay, electrolytic decomposition also we used to call. Okay, another one is say the silver chloride. Silver chloride, when we keep in the UV or sunlight, then it gives out silver plus chlorine. Okay, and the color of the silver chloride will fade. It will change into the black color. So this is called as the photolytic decomposition. What is the name? Photolytic decompositions. Okay, decomposition reaction, and this is called electrolysis. Okay, or electrolysis or electrolytic decompositions. Okay, so this is decomposition reactions. Okay, so I think you are knowing here this one, and you see this is the decomposition, and sometimes decomposition reaction is also called as the opposite reactions of the combination reactions. Okay, now we'll discuss the third types. Okay, so third type is the displacement reactions. Okay, so before going the displacement reactions, so there is the important points about the combination and decomposition reactions. Okay, so sometimes questions arise like this: why combination reactions is also called as the opposite of the decomposition reactions? Okay, so why? Because the combination reaction, in combination reactions, two or more, or you see two reactants combine to form a single product, right? But in the decomposition reaction, a single compound is decomposed to form the two or more products, we can say. Okay, so that's why it is said to be that they are opposites to each other, right? So these types of the question also used to rise. Okay, let us proceed to our displacement reactions. Okay, so those chemical reactions in which a more reactive element displaces a less reactive elements from their compound. Okay, it's called displacement reactions. So here the terms we have to know that more reactive elements, right? Okay, so for example, say here say iron plus copper sulfate, okay, to form iron sulfate plus copper is leaving behind. You know, here in this term you have to know the activity series or reactivity series. Right from the class 8 you have learned this reactivity series. So in this case here, in this reactions, reactivity series that you have to know. So irons and copper sulfate and iron sulfate and copper. You know, copper sulfate is blue in color, you know. So iron being the more reactive, iron is more reactive, so it displaces copper. It kick out copper, and here copper is here, and iron and sulfate, it form the compound iron sulfate. This is the green or greenish in color. Okay, so at this point we have to know. Okay, even here zinc plus copper sulfate to form zinc sulfate plus copper. Okay, why? Because zinc is more reactive, okay, than copper. That's why zinc is more reactive than copper. That's why zinc can displace. But copper plus zinc sulfate, what will happen? What do you think? Is the compound will form? No. So here no reactions. Why? Because copper is less reactive than zinc. Okay, it's like in our families, our big brothers and sisters, they can beat us, right? But we cannot beat them. Yeah, we can beat, but as doesn't look good, so like that types only. Okay, so in the chemistry and all these elements, they are so humble, noble, and very disciplined. Okay, so more reactive elements only they can displace the less reactive elements, but less reactive elements they cannot displace the more reactive elements. Okay, for this you go through your books and you go through your class 8 books. Okay, to reactivity series is given here. According to that one, those substances or those elements which are in the top, they can displace the elements which are in the down, that is in the bottoms. Okay, and most reactive elements, okay, is potassium. Okay, and next comes to the sodium. Okay, and the least reactive elements is gold. Okay, and next comes to the platinums and all. Okay, so these elements we have to know. Okay, so this is all about the displacement reactions. Okay, and now we'll proceed to the double displacement reactions. Number 4. Double displacement reactions. Okay, so this one also we can change a little bit from here. Okay, those reactions in which the reactive elements exchange their ionic part to form two new products. Okay, so in different forms here, those reactions in which the two elements they exchange their ionic part, or you just say they displace the another less reactive elements from one to another to form two new products. Also we can give definitions, we can give two, but I'm writing here only one. So for example, simply as we already discussed, say sodium hydroxide plus HCl, okay, to form sodium chloride plus water H2O. Okay, so in any chemicals compounds here, the first part, this is the metallic generally, okay, and second one is the ionic part. They are the ionic part. Okay, so according to definition, this ionic part they exchange. This will come for here, this will come here. Okay, then here sodium and chlorine, sodium chloride, H2O. Okay, that is H2O. Now water is formed. So such kinds of the chemical equations are called as the double displacement reaction. Okay, we can discuss some more example also. Say barium chloride plus sodium sulfate. Okay, they are colorless only, and here when they react together, here it forms the sodium chloride plus barium sulfate, BaSO4. Okay, and this will get as a precipitate, PPT. Okay, so this is what that we have to know. That is also a double displacement reactions. Sodium chloride, they exchange, this come here, and barium sulfate this one, right? Sure, this come here and this go here, and sodium chloride and barium sulfate is one. So this is about the double displacement reactions, and now we can go for the oxidation reactions. Okay, and will come to the what that is redox reactions and all, right? Okay. This is number 5, right? Myelination, decomposition, double displacement, and this is the oxidation reactions. Okay, those reactions in which addition of, or again also we can say, okay, additions of oxygen, sufficiency about oxygen, additions of oxygens, or gain of oxygens we can say, okay, addition of oxygen, or if we want to say about hydrogen, that is a removal of hydrogen takes place. Okay, it's called the oxidation reactions. Okay, let us see example. So simply carbon plus oxygen to form carbon dioxide, right? Carbon plus oxygen to form the carbon dioxide. Who is getting oxygens? Carbon is getting oxygen. Who give oxygen itself? Give oxygens to the carbon, right? So carbon get oxidized. Who get oxidized? Not oxygen. Okay, carbon get oxidized. Who give? Oxygen give, right? So this is an oxidation reactions. Okay, or let's say magnesium plus the same thing, that is another oxygens to form the magnesium oxide and all, right? So magnesium get oxidized. Okay, so magnesium get oxidized. Okay, getting oxygen and get oxidized, right? Okay, another one is what? That is the removal of hydrogen. Let us see in terms of the removal of hydrogens, or we can discuss about the removal of in terms of the hydrogen. Okay, going to displace, right? So zinc plus HCl to form zinc chloride plus hydrogens. What do you see here? Removal of hydrogen takes place. Okay, from where? That is HCl. By whom? That is by zinc. Zinc get displaced, right? So the removal of hydrogen takes place. So here, this is the reduction reactions. Sorry, what reduction? This is the oxidations. This is the oxidation reactions because okay, removal of hydrogen takes place. Okay, hydrogen get removed from the chlorine, right? And here it formed zinc chloride, right? So this is about the oxidation reactions. Okay, now we'll go to the reduction reactions. It is very important to know oxidation and reductions. Yeah, I'll change here. Number 6. Reduction reaction. Those reactions in which, okay, here just opposite. Here removal of oxygen or addition of additions of hydrogen takes place. Okay, just opposite of the oxidations, you know. Additions of hydrogen and removal of the what? That is the oxygens going to take place. So examples is that magnesium oxide plus carbon to form, what is that? Magnesium plus carbon dioxide. Okay, so this is reductions. How reductions? Here, from here, get reduced. Okay, remove oxygen, right? Magnesium get lost oxygen and get reduced to magnesium, right? So remove oxygen. So this is the reductions. Reductions takes place here. Okay, so this is about that is the removal of hydrogen, and another one is what? That is the additions of the hydrogen takes place, right? Additions of the hydrogens. Okay, what we can give here, additions of the hydrogen. Yes, hydrogen plus oxygens to form water. Okay, so actually this reaction is both oxidations and reductions actually. Okay, but in chance that you can see that is the additions of the hydrogens. Hydrogen get added to the, okay, just according to the types what you want to give, you have to explain. Additions of hydrogens, right, to the oxygen, then to form H2O, right? Hydrogen is added to the oxygens to form water. So that's why it is reductions. Okay, therefore it is reductions. Why, you have to know. Got the point? So there are different other examples. Okay, and such kinds of reactions are called as the reductions reactions. Okay, yeah. And now we can proceed to the redox reactions, or also called as the oxidation reductions reactions. Let us go. Okay, clear, right? Okay, you want more examples? Okay, I'll give the one more example. See, yeah, that is the oxidations only, right? See, zinc oxide plus carbon to form zinc plus carbon dioxide. Okay, number 4, copper oxide plus carbon to form copper plus carbon dioxide, etc. Okay, so many others are also there. Okay, so such types are called as the reduction reactions. Okay, now next goes to the number 7. Okay, so oxidation reductions reactions. Redox reactions. Okay, and or also called as the oxidations reductions or reactions. Okay, so before I am not explaining about oxidizing agents and reducing agents. So here in the redox reaction itself, I will explain you. Okay. Those chemical reactions in which both oxidations and reductions reaction takes place simultaneously. Simultaneously means what? That is at the same time. Okay, simultaneously. Okay, so in these reactions here, both the oxidation and the reductions reactions going to take place simultaneously. That is, at the same time, both oxidation also, reduction also will take place. Let us see now. Example, just we have discussed here also zinc oxide plus carbon to form zinc plus carbon dioxide. Okay, so let us discuss about the oxidation first. Okay, what do you see here? Carbon gain oxygen, right? That's why it is oxidations. Okay, so carbon get oxygens, that's why it forms carbon dioxide, that is the oxidations. But by whom these carbons get, by whom give oxygen to the carbon? Who gives oxygen to the carbon? What do you think? Carbon get oxygen from carbon dioxide. This zinc oxide. This zinc oxide gives oxygen to the carbon. That's why carbon gain oxygen to form carbon dioxide, and that occur the oxidation reaction. Okay. So in this case, zinc oxide is the oxidizing agent. Clear? Yes. This is another case. Yeah, you see, in terms of the reductions now, what do you think? By the reductions, loss of the oxygens, right? There is no hydrogen, so don't go for the hydrogen, just go for oxygens. Loss or removal of the oxygens from a species. So what do you see? Zinc oxide lose oxygens and get reduced to zinc. Loss oxygens. Am I right? So here it occur reductions. Okay, zinc oxide get lost. Okay, oxygens and get reduced to the zinc. But by whose presence zinc oxide get lost oxygens? Okay, if there is no carbon, this zinc oxide will lose oxygen? No. It is because of the carbon. Because of the presence of the carbon, zinc oxide get lost oxygens, right? So this carbon will be the reducing agent. Clear? But little bit confusion, little bit doubtful, right? Yeah, we'll do 1-2 examples here, and at a time only you can know very clearly. So let us see. And I think I will not be able to complete all the types of the reactions here in this video. So for that one, I will make in another video. Yeah, as you see here, some other types of the reactions. Examples of redox reactions. Okay. In the form of questions I will give here. In the given chemical equation, find the substance oxidized. Number 2, substance reduced. Oxidizing agent. Reducing agent. Okay, so in this case, equations is also given here. Say just simple one. We'll discuss first, okay? And say mercury oxide plus carbon to form what? That is mercury plus carbon dioxide. Simple one I am giving you here, okay? Yeah, okay, so financial use here HCO plus carbon to form Hg plus carbon dioxide. As we know, carbon get oxidized, right? So answer number 1 is substance oxidized is what? Carbon, not carbon dioxide. Okay, if you write carbon dioxide, that is wrong. Carbon dioxide is the product form after oxidized. Okay, so this is the oxidation system here. Okay, and substance reduce. Substance who will get reduced. Okay, so mercuric oxide, before mercury oxide, and then it reduced to, there is loss of oxygen and their reduction occur, right? Substance reduced is not mercury, this is mercury oxide, not mercury, mercury oxide. Okay, and number 4, oxidizing agent. Yes, who get oxygen? Carbon, right? Who give by oxygen? No, mercury oxide. Okay, HgO will be the oxidizing agent, right? And number 4 is the reducing agent. What is that? Because of who's present, whose elements present here, mercury oxide loss get reduced to mercury, or loss oxygen, carbon, right? So this will be carbon. So these things you have to keep in mind, okay? You have to keep in your mind. So oxidizing agent and reducing agent, okay? So this is all about oxidations and reductions. Copper oxide plus hydrogen to form copper plus H2O. Okay, so this is also an example of the redox or oxidation reduction reactions. Okay, what do you see here? What do you see? Copper, and it become copper. What do you see here? What is this? And what do you see here in hydrogens? Okay, just forget about this. You cannot mix all the thoughts together here. Copper oxide. What do you see here? There is the loss oxygens. If any, from any species oxygen is lost, then what do you say? This is oxidation or reduction? Loss of oxygen is the reduction, right? So here reduction reaction takes place. Okay, and then here hydrogens. Hydrogen get lost, or it can. Okay, this is loss of oxygen, and in this case what happens here? Hydrogen is added. Hydrogen is added to the oxygens, right? Then really no. Hydrogen is also getting oxygens from here, right? Yes or no? Oxygens here it is given to the hydrogen, right? Then here this is also what? Oxidations. Here is the oxidation reactions, because hydrogen gain oxygens. Hydrogen gain oxygens from the copper oxide. By whom it give? Copper oxide. Okay, copper oxide give oxygens to the hydrogen to form water molecules. So this is an oxidizing agent. Okay, and the copper oxide get lost oxygens. Okay, and reduced to the copper. Then by who's present? By due to the presence of hydrogen. So this is an reducing agents, right? Yeah, this is all about the oxidations and reductions reaction, that is the redox reactions. I hope you enjoyed the video, and we'll proceed to the next chapter the next day. Thank you all. Don't forget to subscribe. Thank you.